combine hydrogen gas and oxygen gas. I'm wearing earplugs because the explosion can be very loud for the person nearest, but it went well in period 1, so everyone else should be pretty safe. So let's go ahead and go over the agenda. Okay, we just did our iReady, warm up, waterfall. I'm going to lead the experiment. We'll have a discussion. We'll take a cell phone break. There'll be some practice that you do by yourself. And you're going to watch a video. Period 1 is doing ed puzzles because they can't discipline themselves to stay focused on the video. So they're just going to work by themselves. But your class is much more focused, so we're going to do video notes. Huntingdale. Part 6. Part 5, actually. All right, so we're trying to explain why does a small spark cause a huge explosion. Did we do part 5 yesterday? I thought I saw it. Oh, part 6. We're doing part 6 today. Thank you. Okay, so we're trying to explain why does a small spark cause a huge explosion. I'm going to try to give you a huge explosion up here, but first we're going to do the separate gases to show that they are separate, and then combine them so that they can get you thinking. So we can get you thinking about and wondering about why it happens. Let's hear from our waterfall participants. Aiden, did you do the waterfall? No? Okay, you can. We'll come back to you. Pedro is not here. Elias is here. Did you do the waterfall? Yeah. Okay. Let's hear Elias's response. What do you predict will happen to the oxygen and hydrogen atoms? They will combine and they will cause an explosion. So let's take a look. Here they are separate. Here they are combined. Why would a combination of atoms cause an explosion? What do you think? Any idea? Tell me about why atoms come together. Benjamin, you can go. Why do atoms come together? They have an attraction, right? They have an attraction. So class, whenever you see atoms by themselves, like these little circles, you should already be thinking about how they'll interact. And so far, Elias predicts it will attract. And why do they attract each other?
Because they have
Positive and negative charges, right? Positive, negative charges. So these will attract, and when they attract, they form a bond. They form a bond. And you can see here that Elias's prediction of the attraction between the atoms is true. Look at them, they're locked together with these double lines or these single lines. I'm going to combine hydrogen gas and oxygen gas and see if they can become bonded together and create a huge explosion. Let's hear from Aiden. Aiden, did you finish yet? Can you start working on it? And Edwin, you got to face forward, otherwise I'm going to think you're on your phone. All right, well, got to face forward. Let's go to the student above Elias, who is, it's actually Edwin. So Edwin, go ahead and read your response. The chemicals will create new bonds. Why do atoms attract to other atoms? Instead of atoms going away, they combine. Because they have opposite what? Like, don't atoms have a positive and some have negatives, so they attract? So why would energy be released if they come together?
because
They're creating new bonds, but why would that create energy? Think about when they get too close, what happens? Don't they push away?
Yeah.
They push away. So class, even though there's an attraction between atoms, there is a pushing away if they get too close. Camilla, you got to pay attention. I know it's period 3, but you still got to stay awake and learn chemistry. Okay? All right, maybe these explosions will wake you up. So let's go ahead, class, and close your screens. Everybody close your screens. And I'm going to take the elements that I have on this table to produce 2 types of gases, and then combine them, and then show you what the energy is like. So the first gas I'm going to create is oxygen. We did this with the test tube hands-on activity. So I just took hydrogen peroxide and something called manganese dioxide, and I combined them, and it made a whole bunch of bubbles in water. But this time I'm going to put soap and water together so I can light the bubbles with the flame and watch them explode. So I'm going to go ahead and put the manganese dioxide into this flask. And then I'm going to put some hydrogen peroxide, same stuff that will, okay, this tipped over, so I'm going to start over. Wasn't expecting that. I have a bucket in here also that will collect the manganese dioxide. Alright, so let's try again. I feel like I'm at a cooking show. Alright, so about 2 tablespoons of manganese dioxide is going to go in this flask. And there is some manganese dioxide on the edges. I don't want that to block the cork. So I'm going to go ahead and throw that away. But now I'm going to put the cork. Oh, let's put the peroxide in. All right, you see how it reacts right away? So this is oxygen gas. And then I'm going to collect it into this soapy water. So watch how the bubbles produce inside a soap, creates soapy bubbles. Now, what was the property of oxygen bubbles? When I'll hold it up in a minute. Oh, actually, you can actually move your chair if you can't see. What did oxygen gas do to a glowing splint? What did oxygen gas do to a glowing splint? You guys remember? It did what? It made it brighter. It made it brighter. So I'm going to go ahead and light these oxygen bubbles with my glowing splint. So this will not explode. This is just a glowing splint. Right? I'll tell you when it's going to explode.
Oh, okay. Are you trying to kill us? You ain't gonna be able to tell us it's already dead.
Alright. I also want to change this slide so that you can see the glowing parts better. Okay. So this is glowing. Watch what happens when the splint touches the bubbles. Okay, let's do a better splint than that, because that splint was minimal. That was a minimal splint. Let me see if I can get some more bubbles. Remember, this is, oh, I didn't tell you, this is recorded. Okay, this is recorded so that students who are absent can see it. Okay, so don't say your name. Okay, on video. Just make sure you are not saying anything you regret later on. Okay. Yeah. So just be mindful. Okay, here are our bubbles. And then I'm gonna light this paper towel again. Let's use a dry one. Okay, I'm gonna get a longer glowing splint this time. Okay, definitely gonna be longer. All right, there we go. Glowing splint. Let's put it to some oxygen. So did it get brighter?
Yes.
Absolutely. It got so bright it caught on fire.
Oh my God.
Okay, next is the these paper towels really.
You should really stay with that.
All right, next is the hydrogen gas. Okay, so now we have oxygen gas. Now let's make hydrogen gas and then light that on fire next. So to make hydrogen gas quickly, I'm gonna take these pellets called sodium hydroxide, and I'm gonna add it to just water. And this is some leftover from last period. I'm gonna put aluminum inside, and it's gonna make a gas, the hydrogen gas. Maybe I'll use a smaller piece. So this goes inside like that, and then I'm gonna put the cork on, and the gas that forms from the melting metal will produce hydrogen gas. So we're gonna give it a moment. If this is too watery, I have an extra flask that I can put the the pellets and the water in, and the aluminum foil. But this was working earlier today, so let's let it completely coat the aluminum, and I'll stick this in the soapy water, and we're getting some bubbles. We'll let it do its thing. Aluminum does have a coating on it, so it won't react with the sodium hydroxide right away. It is kind of slow. Let me see if I add more water, if that makes a difference. Because it has to be water and the pellets mixed together.
It should smell worse now.
Alright, so now there's more water. And let's see if we get more bubbles. Okay.
Mr. Liam, the science guy.
It's not a bad song. So that's pretty slow. So I'm gonna start over with a new flask, because it's kind of like, you know how soda gets flat and it loses its energy. I think the same thing happened with this sodium hydroxide. Or we can combine two flasks and have two flasks going. All right, my hands are dry. Let's add these pellets. These are white pellets of sodium hydroxide. All right, I just pour it in like that. I'll do a few more. And it did take a while for it to completely dissolve in period 1. This experiment took 17 minutes, which is longer than I wanted it to. Well, if I look at this, we do have some hydrogen gas. So let's just use up this hydrogen gas for now. And I'm just going to directly light it. What does hydrogen gas do when it's in contact with the flame? Who remembers? It pops. So let's see if there's a pop.
Oh.
How many heard that? Okay, very faint pop, but not the same sound as the oxygen. The oxygen didn't even make any sound at all. So now let's combine the two. Let's combine the two together. This is so slow that I'm not going to depend on this one for hydrogen gas, but I will make a new batch so that we can have a larger explosion. So I'm going to pour some water in. And let it dissolve. And then I'm going to put the aluminum in. And this is a lot more complicated than just mixing hydrogen and oxygen. The aluminum is bonding with the oxygen in the water, leaving hydrogen by itself to bond. But let's see if we can get some hydrogen gas and get some oxygen gas to mix together. All right, so we'll put the new cork in this. And as soon as this starts melting, we can mix it with oxygen.
It's gonna turn black like that?
All right, so it's still, was there a question?
Was it gonna turn black like the other one?
Yeah, so eventually all the aluminum becomes like a powder and it starts to block light, so it looks darker. But eventually it'll be clear and all the aluminum will sink to the bottom. So it does look darker because light is being blocked. Let me add some more pellets and some more water, and then we'll get more hydrogen gas. And if you do have sensitive hearing, just cover your ears for the first one, and then if you feel like it's safe enough, you can take your hands off of your ears the second time. So I'm going to do it twice, the hydrogen oxygen explosion.
No, he gonna show it to the people that's asking. You have to
All right, it's starting to speed up.
Get that money, y'all.
Slowly but surely, let's add a little more water. It's definitely producing, I don't want it to go too fast because I don't want it to run out by the time the oxygen's ready. Because I have to repeat the process with the oxygen too. Okay, so we're getting some bubbles now of hydrogen gas. So I'm gonna put this inside of this bucket. Okay, this bucket's gonna share the bubbles with oxygen now. So let's go ahead and do this. This keeps curving, so I'm gonna rotate this. Okay, so it's starting to go on that side. Let's just combine it on that side. All right, oxygen time. So we've got some oxygen here, but I think we can do better than that. We can get at least a pile of soap bubbles for oxygen. I'm gonna pour more hydroxide in. And then I'm going to swirl this around. Oh, we got a lot now. Okay, so let's go ahead and place this in here. Scoot this over. And stick this into the hydrogen mixture. Okay, I'm going to do a little bit first. Okay, a little bit the first time. It would be nice if the bubbles were different colors so I could tell which is hydrogen, which one's oxygen. But the fact that they mix is going to be good enough. So I'm scooping the bubbles out this time. So I do not want this to pop in the bucket, at least not right now. All right? Watch this.
Oh, I got the pump. Oh, let's go.
Go ahead and clap so the security doesn't think I'm trying to do anything. Go ahead and clap. Okay. Is everyone's ear okay? Okay. I'm going to do it one more time. I'm going to do it one more time, and you can video record this or cover your ears or whatnot. All right?
Oh, hey, Rappy Beats.
Hold on.
Oh, hey, Rodney_Beast12. Rodney_Beast. You know what that is too? Oh my God, bro.
Okay.
Y'all heard that?
That's just good.
If these bubbles are stuck, maybe I just get more bubbles. All right, that's good. Okay, are we ready? So this is hydrogen and oxygen gas put together. Okay, that's all I'm gonna do. My ears are ringing right now. So give me applause. All right, everything's fine. And I'm gonna give it a rest because my ears are killing me now. All right. So I want you to think to yourselves, why did this happen? Why is the mixture of hydrogen by itself different from the combination? Why is the mixture of oxygen by itself different than the combination, right? So think to yourself about 10 seconds, what is it about the two combining? So take like 5 more seconds. And you're going to share with your shoulder partner. Okay, share with your shoulder partner what is the what's a reason why it might have more energy. Okay, and the person with the most siblings is going to share first. The person with the most siblings is going to share first. Why is there more energy? You don't have to write this down. Just have a discussion. Why does it have more energy? Why is there more energy when they're combined? Why does this have more energy than just this? Why does this have more energy than just that? What do you think? Take a guess. Who has more siblings? What do you think? Why is the combination having more energy than when it's by itself? Another thing to combine.
No.
All right, let's hear from the class. Let's hear from Geraldine first. Chosen. So Geraldine, why does the energy, why does it sound differently or even feel differently than gases by itself? What was combined? What does this say? What's in here? H2, which is
Water.
SH2O.
Oh.
H2 is hydrogen, and then Geraldine, we have this gas here, O2, which is oxygen. So we combined the two together,
Oh, break time.
and then they became. So we're gonna hold the break. We're gonna hold the break. Then we'll take a break in like 2 minutes. Okay. Break is on the way. Let's just get this learning done. So what is the? Why would two make more energy than just one by itself? Look at these atoms here. We have oxygen, just like you described for us, and hydrogen. And when they come together, what do you observe happen? Describe it. Are they still free to float around by themselves? What are they doing? They're what? They're combining. So when gases combine, they look like this. And then tell me about the energy released. This is energy stored. Tell me about energy released, Geraldine. It goes up, it gets higher. So when you explain why things explode, class, you have to include that the atoms come together, and when they come together, they release energy. This is kind of what Elias was referring to, and so was Edwin. And the reason why they attract, let's ask another student, thank you, Geraldine. Alexandra, why did the hydrogen and oxygen even attract at all? They make water, right? Does everyone see that? Let me pause it for a second. Look at this. 2 hydrogen, 1 oxygen makes water. But why? What is inside the oxygen? What's inside the hydrogen to make them attract? Your classmate said it earlier. Why does anything attract? Let's say the oxygen is negative. What is probably the hydrogen? Probably positive. So class, even though we learned positive and negatives attract months ago, right? Months ago, it still applies to why things will explode with a small spark. And we have hydrogen and oxygen, positive and negative attracting, and then they form a combination called a bond, and then energy is released. But why is energy released? This is the last question, and then you can take your break. All right, so thank you, Alexandra. This is to Kylie. So Kylie, why would energy be released when 2 atoms combine? Let's go ahead and use the golf ball phenomenon to explain it. What happened to the third golf ball? What happened to the third golf ball? The third one. It moved. What moved the third golf ball? The first golf ball. So, Benja, if you could focus for a second. When we have 2 atoms acting like golf balls, they're going to hit a third atom if there's enough energy. Is there enough energy, Kylie? Absolutely. This transfer of energy is called the explosion. This transfer of energy is called kinetic energy release. And what you heard was the sound. If the lights were even darker, you would see the light. Did anyone see a flash of light? Okay.
I was too scared.
Well, maybe you'll watch it in slow motion when the video is uploaded to YouTube. We can go frame by frame. There should be some heat, some light, and some sound every time 2 atoms are attracted to each other. And Kylie says, hit a third atom or hit a third golf ball. All right. In your assignment after our cell phone break, you will practice this knowledge and learn it even deeper. You'll apply this knowledge and learn it even deeper. Question? Yes. All right. You may take your 5-minute break, everybody.
Just to go back to
And I'm going to need the video recording airdrop on my phone. Do you want to see it?
It wasn't no video.
There's a photo?
No, that was the video ended too early because I got scared.
Okay. That is understandable.